Uy, Jaya, paano ba isolve tong orbital diagram? Tapos itong 3 general rules, ano ba yan? Hindi ko maintindihan.
Oh, that one? Oh my gosh, that's only BASIC basic. So easy. And you don't know that? All you have to do is go to YouTube, search the basic of physical science, and watch this video. And you can learn all about electron distribution.
Good morning, everyone. Welcome to the basics of physical science. Today, we are going to discuss in each about the electron distribution. But before we start, what is electron distribution? Electron distribution is an important factor in understanding chemical reactions.
We'll talk about electron configuration. Electron configuration uses symbols of the orbitals as well as the number of electrons that occupy each orbital. Next, we are going to have an example for electron configuration. Please refer to your periodic table and find the atomic number of magnesium.
For example, magnesium. Magnesium has an atomic number 12. Please refer to your periodic table's electron distribution mnemonics. Take note that S has a maximum number of 2 electrons, P has 6, D has 10, and F has 14. Always remember that its atomic number should be equal to the electrons. Let us proceed to the another example, which is phosphorus. Its atomic number is 15. However, we have 3 general rules in electron distribution. The one applicable on this is the Aufbau's principle. Aufbau's principle states that you need to fill the maximum number of the sublevel before going to the next one.
An orbital diagram uses boxes with arrows to represent the electrons in an atom. Each box in an orbital diagram represents orbital. Orbitals have the capacity of 2 electrons. So, in writing an orbital diagram, we must remember the equivalent of orbit or box in each sublevel. S, P, D, F. The sublevel S is equal to 1 box or orbit. The sublevel P is equal to 3 box or orbit. And the sublevel D is equal to 5 orbit or box. And the sublevel F is equal to 7 orbit or box.
Now, let us talk about the Pauli's exclusion principle. In this principle, there should only be a maximum of 2 electrons in an orbital in opposite directions, 1 arrow facing up and 1 arrow facing down.
For this example, the arrow should be up, down, up, down, up, down, 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 up, and down.
Now, let's talk about the Hans rule. In Hans rule, within an orbital, place 1 electron per box before pairing them. The arrows in the first part is up and down, and the next, up and down. For the next part, fill up all the boxes with half arrows up. Only then you can add the half arrows facing downwards. In the last part, there are only 3 electrons. This is the part where you can determine the result of unpaired electrons.
For our last example, we'll be using the atomic number 47, which is silver. I added the maximum number of electrons on each sublevel before moving on the next one. For the last sublevel, I only wrote 9 since 47 should be the total amount of the electrons. On the orbital diagram, make sure that the number of electrons are the same with the number of arrows you're adding in each box. In the last set of boxes, I added the half arrows facing upward before adding the half arrows facing downward.